Hey guys, so welcome to our malware tricks course. This time we're gonna be talking about code injection techniques class. Okay, so the first technique is being called CreateRemoteThread, which is basically the API being used by malware in order to infect processes. As you remember, malware is gonna be trying to inject into other processes into the system in order to hide from the operating system, and also in order to make it difficult for us as analysts to understand what's going on. So as you can imagine, in a real scenario, the malware can be running and eventually it will inject into a process like Explorer or Internet Explorer or Microsoft Word or any other well-known process. And therefore, if you try to see what are the processes running in your system, you won't see any difference, and it's going to be more difficult for us to understand if our system is already infected. Okay, so what we are going to learn here, guys, is how we can identify when a malware is doing injection using the CreateRemoteThread technique, and how we can be able to find it in memory, the malicious code being injected, in order to analyze it properly. Okay, so let's start with our example here. So we have here CreateRemoteThread. This is the binary that we're going to be using. We just send it to IDA so that IDA can start analyzing it. Okay, IDA is going to start analyzing it, and in the meantime I'm going to also open it with Immunity Debugger, which is the debugger that we are always using, guys. Okay, so here we're ready. As you remember, I highly recommend to always use the debugger for runtime execution in order to know exactly how the variables are looking at real time, how the malware is behaving, but also very important to have the full context of what's going on is to open IDA and follow the disassembly. Okay, so let's open it IDA. I'm going to maximize this window, and when you are dealing with injection, assuming the malware is not packed, you might want to look in the imports for write process memory. Write process memory is a main indicator of injection, because write process memory API is used to write specific bytes into a process, and actually into any process in memory, depending on the permissions, but it is the API being used. Okay, so let's click here the letter W so that we can go to the W APIs. We can see that write process memory is present. That's telling us that might be injection. When dealing with CreateRemoteThread technique, normally you are gonna be looking for a couple of APIs that we're gonna see in a second. Okay, virtual alloc is one of them, to allocate space in a remote process, write process memory to inject into it. We can see here also the create tool health 32 snapshot, which is used in order to start enumerating processes in the system, so everything is start getting connected, right? So let's go to that specific code of this specific binary related to injection. As you know, that's the scope of this class. We are not dealing with the whole understanding of the binary, just dealing to how to identify when the malware is injecting into another process. Okay, so let's double click on write process memory. We can see it here. From here we click X to show us the X references, in other words, where this API is being used in the binary. We see it is one time only. We double click on it, and you can see here, right guys, that we are in the real meat. This is a normal process that you're gonna see all the time. You can see an open process, which means open a process with certain permissions, normally the process that you want to inject, and then once it is open, virtual alloc in order to allocate a buffer into that process remotely. Once that buffer is allocated, write process memory to write into that process, which is right there the injection into the new process. And finally, the create remote thread, which basically is saying go into that process and start executing at this specific address pointed by lp start address parameter. Okay, guys, now let's get, this is the whole injection, right? But let's grab a little bit of context before that. So what was the trigger in order to reach this specific function? We can see that first it calls the window thread process ID, and if that process ID was found, it will go and open the process. But if not, it will just get out of the loop. In other words, it won't do any injection. So it's kind of trying to find a specific process ID. This get window thread process ID is the process ID of the current window thread. In other words, the malware is trying to find a window and based on that window get the thread process ID. That means that there must be a call to find window to first find a window and then get the process ID of that window. So let's go a little bit backwards. Here we can rename this specific function to injection, right? So that we know right away. It says that the length exceeds the maximum amount of length. We said is fine. So we have here the new name so that we can distinguish it. If we click X into that specific function, we can see that it is actually being called 2 times. Okay, so let's go to the first one. So here we can see that just before getting into that function, it is called find window, which was expected. And find window, you can always, guys, go into MSDN to know what is exactly this function doing. Okay, that's highly recommended. IDA is going to also give you the parameters, as you can see there. So this parameter, which is the third one, is the class name. In this time, we can see that it is progman, which is a class name related to program manager. Program manager in the old version of Windows, it was the file system. No, it was the interface to deal with archives, to deal with folders and files. It was called program manager. Nowadays, with the latest Windows, is basically Explorer. You know, Explorer, which, as you know, is our software within Windows in order to deal with files and directories, which is exactly this, right? This is what we call Explorer nowadays, this window. So what it is doing basically is saying, hey, find the window related to the class program manager, which is exactly this window. And the reason it wants to try to find it is because later on, once it finds it, we'll grab the process ID that generates that window. And with that process ID, we'll start injecting. So potentially, what we are looking here is the malware trying to inject into Explorer process. Okay, so let's confirm that. I mean, as I said, we can go backwards, but that's not the idea. We are not going to deal with other thing but injection. Okay, so we have a context. We have context enough. So we're going to come here. I'm going to press space just to see what is the address here. We can see that it is 40D006. Okay, so I'm going to go to this guy. I'm going to click on Ctrl G. So 40D006. Okay, you can see that we are right there in the find window. So we just set a breakpoint by pressing F2 and play to let it go. Okay, we see that the EIP is pointing to 40D006, which is exactly what we were trying to stop the program, and we are ready to execute. So right here, a find window is going to say, okay, go and find the window of with the class name program. Okay. If found, it will return in EAX a handle of that window, and if not found, it's gonna return 0. So let's press F8, and we can see that right away EAX is pointing to a value, which means it's our handle. Okay, and then after that, it is a push EAX and something extra. Let's go to IDA, because that's our friend, which can give us more context. We can see that it is our injection. Okay, so basically the window handle is going to be pushed into the next function and is going to be used eventually. Here we can see that here is the first parameter. You know it is the first parameter if you remember when we talk about the stack. Okay, the stack in memory, you can see the letter R right there, and above letter R are the local variables in the function, and after the letter R are the parameters. And you can see that the first parameter in this case is HWND, and the second one is the buffer. Okay, so the first parameter is HWND, and makes sense because, as you remember, it was the push EAX. Okay, after that, this parameter, as you can see, is going to be used exactly here. And if you remember also about the standard call, this is the first parameter being pushed into the Windows thread process ID, which is needed in order to find the thread associated with that window, which is going to give us back the process ID that created that specific window. Okay, so again, guys, if you don't know what is get window thread process ID, in this case I know what it is, but if you don't know, don't hesitate, just go to Google. I always do the same, and go here like get Windows thread process ID, MSDN. Make sure to put MSDN, and see, MSDN is gonna say, okay, so you will need a window handle that we know, and then it's gonna put in a buffer the process ID related to the thread that created that specified window. Okay, so we know that, and then that's why also IDA is labeling this. So let's see if we get the process ID. After that, the result is going to be stored in EAX, and let's confirm that specific step in our debugger. Okay, so we are here, we step into the injection function with F7. Okay, and then here we just F8 quickly in order to be ready. We stop in the call before executing it. Let me just expand this window a little bit. Okay, and then we are ready to execute. In the right side, we click here in the xdump to put a 32 byte view. Sorry, 16 hexadecimal view, so we can see 16 bytes instead of just 8. You know, it is better. And here in the right lower right side, it is a stack. So we can see that here is the program manager. In Unity Debugger is parsing it for us. Is the program manager is the name of the window, and the class is procman. Okay, and here is the buffer, which is going to store the value. So we right click, say following dump, so that we can wait right here for the result. Okay, so then we click, go back to the main function, upper left window, and we click F8 and check the window in the lower left side. You see, it says 9805. Keep in mind this is the window. In other words, it is little endian, so we need to reverse it. In other words, this means 598 hexadecimal. So we open our calculator, we go to programmer view, and we enter in hexadecimal 598. we convert it to decimal, and we know that it is the ID 1432. So let's click Window Run Task MGR, which is the task manager. We go to options, to view, select columns. We say also include PID. Okay. We order PID, and if we go to the 4032, look at that, guys. The PID 4032 is explorer.exe. So we just confirm that the malware found the class related to Explorer and then extracted the PID. Okay. Now that the malware has the PID, let's go back to IDA. The malware just got the PID right here, which is, as we know, the plus Explorer proc ID, right? We just put some notes always. And then with that process ID, it's gonna come here in open process. And it's gonna say open process, where the first parameter is 42A, which is the desired access. And the second parameter is the inherit handle, which don't care about it. And the third parameter is the process ID, which we just got, which is this guy that we just got with via get Windows thread process ID. Okay, it's gonna open it. Basically, this function is gonna say open it with some specific permissions. The permissions are 42A. Okay, again, let's say that you don't know anything about open process. We can always come in MSDN open process. We go to open process, and you're gonna see here that the desired access is this specific value, and it has some process access rights. As you remember, we have the value 42A hexadecimal, 402A. Okay, so if we scroll down, we can see here the 400, which means process query information. It wants to retrieve certain information about the process. So in other words, it is requesting to open the process and get this specific information, which is process query information, which is 400, but we're still missing the 2A. So the 2A comes here. We have the 20, which is process VM write, which means required to write to memory in a process. In other words, I want to open this process and be able to write into it. Okay, so, and finally the A. The A can be this process VM operation, which is 8 number, and then if we added 2 more, which is process create thread, that gives us 8 plus 2 is A hexadecimal, right? So finally, if we zoom 02, 400, 8, and 20, that's all the privileges that we are seeing in the 42A value. Okay, guys, this is so that you know how you can calculate those values. So let's again, as usual, confirm that with Immunity Debugger. So we come here, it compares if it is an error, there is no error, then it comes to open process. You can see that Immunity Debugger is really helpful enough, and it is saying, okay, this 42A is the combination of create thread, VM operation, VM write, and query information, which is all the different options that I just described a second ago. Okay, so then open process is going to execute. We click F8. It gave us E4, which is good because if it returns 0, that means it's an error. So everything is fine. Here the malware is going to call get last error to compare with 0, which is not the case, and therefore the jump is taken. In other words, there is no error. And then, guys, with that process ID, we're going to come here with virtual alloc x. Okay, let me expand this a little bit. Now, again, if you don't know what is virtual alloc x, go to MSDN as usual, but I can tell you here right away. So the first one is the process ID that we just gathered, in this case explorer.exe. The second one is the the offset in memory of that remote process where we want to allocate data. In this case is 0, which means I let it up to the function to decide what's going to be the base address of that buffer where we're going to be allocating. In this case, the buffer in Explorer process where we're going to be allocating memory. Okay, the third one is the size to be allocated. No, sorry. The third one, what is the third one? I think it's the size. And the fourth one, I don't remember, guys. So let's quickly go. Virtual alloc x. I don't remember if it is the size. I think it's the size. Yeah, I think it's the size. Let's see. Yeah, it's the size. So it's the process, then it is the address that is gonna be used in the remote process where the buffer is gonna be allocated, the size of the allocation, the allocation type is this one, and flprotect is what is the values. Okay, so flprotect, that's also another kind of flags. So if we go to the fprotect memory constants, okay, we can see that it has different flags. It has 10, 20, 40. This 40 is the one being used by our malware, which is execute read write. In other words, I want that specific memory to be able to be written, read, write, and execute. In other words, I want to write into it and then execute from there. 40 is a very common one, so you can see it right here. Okay, guys, so we are going to execute it, and in EAX is going to return whatever is the offset in memory into Explorer that is going to be used. We click F8 and we can see that it chose F30000. Always write down that value because we're going to use it. So we set Explorer new buffer allocated, it is F30000. Okay, guys, and then once the process is allocated, we are ready to write execution. We set here again if there is any error, no error, and then we go to write process memory. So write process memory is also saying, okay, the ID that I identified, which is Explorer ID, the address, as you can see, which was just allocated, the buffer, and this is very important, guys, is the buffer that is going to be written into that specific process, is the malicious code that is going to be injected. So if we right click here and say follow in dump, we can see in the left side what is going to be written, and the bytes to write, you can see it's kind of high. It is 14,300 bytes. So you can go down and you can start seeing a lot of information there, guys, you know, some strings there, so many things that the malware is gonna do after injecting. Okay, guys, and then it says bytes written. This is just a buffer where it's gonna receive whatever was written. Okay, so then we click on F8 and it says 1 means everything was fine, 0 means there is an error. Again, the malware is gonna check if there is any error, but there is no error. And then the final one, guys, which is CreateRemoteThread. CreateRemoteThread is again gonna use the process ID, and the most important thing here is the 1, 2, 3, the fourth parameter. The fourth parameter, guys, is exactly the offset where this specific piece of code is gonna start executing into the injected process. In other words, as you remember, it was injected into the fifth parameter, this base address for F30000, and then in F33334 is going to start executing. And here is the trick, guys. So if you click on F8 right now, Explorer is going to be injected or infected, and then we lose track, right? We don't know what's going on after that. So it's we're gonna lose control. So we wanna wait for that injection in order to start executing to Explorer. So how can we do that? Let's open Explorer, put a breakpoint into that specific offset, and wait for it right away when it start executing. Okay, so we know that Explorer is being infected, so we double click on immunity again. So we open another session, we click on attach, and then we can see here is Explorer. This guy 1432, if you remember, is the process ID which was just infected. We attach to it, and here is one thing very important for you guys. Since we just attached to Explorer, so the lower bar where we have all our tasks is gonna be locked. So if you try to click on something here, it's not responding. Why? Because we just attach into the main Explorer, which is dealing with those guys. So if we click here go to let it run, you can see that we recover actions, right? We can again interact with the desktop. Now here we just attach to the process which was just infected. Actually, if we go right now with Control G to 00F30000, sometimes it doesn't jump at the first time. Let's do it again. That's a good point, guys. Sometimes the enter expression to follow doesn't work at the first time for some reason. You just do it again, Control G, and you can see, if you remember, guys, these were the first bytes into that buffer copied. Okay, so let's go now to the offset where it's going to start executing, which, if you remember, was 00F33334. We click enter, and then here, guys, we're going to put a breakpoint. Okay, we're going to put a breakpoint right here, so that as soon as we click, we let run the other session of the debugger via CreateRemoteThread. It will start executing, and we are going to wait here for the malware to jump and start executing, but we control it via the breakpoint so that we can keep executing the next malicious actions. So let's do that. I'm just go to the previous session, and I'm gonna click here, guys, F8. Okay, and for some reason you can see that now the Explorer is locked. And guys, if we go to the other window, voila, you can see that the EIP, it is pointing to F3334. Explorer is paused, as you can see, and we just break exactly at the time that the malware jump into the new process. From here, you are ready to start executing the next malicious actions. As I remember, to start executing and obviously understanding the next malicious actions. As always recommended, you can right click here, say following dump. So in the lower left memory window, you have all the information from this specific malware. And what you can do, guys, is always right click, backup, save to file, so that you can have this specific shellcode. You can save it on disk, whatever you want. You save it, guys, because what you want to do is you want to open that chunk in IDA, and again with IDA and with the debugger start understanding what's going on. So after this, guys, it's out of the scope of the class, but you can see here that the malware start executing, and you are ready to see exactly what it is doing after the injection. You can see that here, for example, we don't know what is EDI, but eventually, it is a get module handle, which is kernel 32. So you know it's gonna start doing some other actions, but as I said, it's out of scope. But you guys learn how you can follow a process injection when using the CreateRemoteThread technique. Hope you enjoy it.